So welcome, yes. Thanks so much. I'm speaking on behalf of George and Dave, who can't be here today. I think George might be joining us right away. So yeah, thanks for that introduction. It's great to be able to speak on this. This is a fun applied research project funded
Yeah,
by.
thank you. Right.
Hello? Are we good? Is it working? Okay. Perfect. This is a project is funded in part by the Lethbridge College, SOTL, and Cariff grants. We are George, George, me, and Dave Mays. We're instructors at Lethbridge College. George is in the broadcast journalism program. I'm in computer information technology, and David Mays is in justice studies. This talk today, we're going to talk about a little bit of the problem/opportunity that came up and our solution for it. A little bit about the research that has come from this, and some about the future work where we're going to go. So the problem really is that learning and practicing verbal interpersonal skills is expensive. If you want to learn to talk to people, I can tell you how to talk to people. I can say, these are the kinds of words you should use in this situation, and you will nod wisely and think that you know what you're doing. And we've all experienced this. Someone says, all you have to do is say this, and then you get in the situation and you maybe freeze up. And this is actually a thing that happens with our students. Some of the ways that we have worked around that is with simulations, talking to a screen, or having live action role plays. And some of these things come with challenges. Like flat screens are flat. You don't get the immersive experience. Most of those simulations also require an instructor to be sitting there, which takes time. And if it's one student, one instructor, then you are constrained for time to get through a class of 30. There's also the problem of observer or controller bias, when most of these situations or simulations rather rely on a knowledgeable instructor to judge whether the person has said the right thing, and that can be open to some bias. Also, if you're doing live action role plays, that requires actors, and that's expensive. I'm going to attempt to play this so that I think if I have done this correctly, we'll be able to hear Dave Mays talk about the problem. If you can't hear it, there we are. Let me try that again.
Help his students. Meet Dave Mays.
As an instructor in the School of Justice Studies, had a course called Crisis Intervention. And in that course, we're teaching communication skills to students on how to talk to people, interact with people that are in crisis situations.
In that course, students will be taught the theory in a classroom setting before moving to a simulator that consists of a flat screen and uses a series of videos to mimic a scenario. These systems tend to be slow to react, and students felt it wasn't a realistic experience to prepare them for the real thing, live actor role plays.
Students are dispatched to a call as if they're working in partners as police officers, and they could go to any type of call. And they get upstairs into the apartment, and all of a sudden they're faced with two real human beings. And students, especially on the first one, weren't doing well. They didn't have a lot of confidence. They didn't have a lot of practice experience. So we were missing. There was a gap in their experiential learning. I was at a buddy's place and we were playing around with VR. And I was thinking to myself, this would be really cool if we had a scenario. But what we found out very quickly is that what we wanted to do actually didn't exist, and we would have to build it from scratch. And
So that's really the genesis of this this solution. So what we came up with was, by we I mean mostly Dave and George, automated scenario role plays in virtual reality. So we have multipath scripts. This is like choose your own adventure style. It's filmed with 360-degree video to give a very immersive experience. You are sitting in the car. You are standing on the street with somebody yelling in your face. And as Dave frequently observes, there are students who go into policing, for example, who have never had someone yell at them. And so this has been quite the eye opener for some students. So this solution in VR has the scene advancing when the student says the right thing or does the right thing. There are radio devices. There's binoculars. There's remote controls. There's a notepad. There are lots of different assets that we've put in, but ultimately we also want, it's about verbal skills, so we're going to have them say the right thing. So each of the scenes that we develop is a multipath script, and this is just one example from one of our scenarios. This is a domestic dispute, and typically an entire scenario will run 4 to 8 scenes, and each scene could have up to a dozen clips in it. So each of these boxes would represent some film clip and some notion of the dialogue, and then UV is where there's a user voice interaction where the user actually says something to the system and the system will respond. We put everything together using Unity as a gaming system. We have we've got the 360-degree video loaded in. We have done a few things in terms of managing some motion sickness kinds of things that can occur, in terms of just making sure that when you move a little bit, the perspective changes appropriately so you don't get that motion sickness. We've also in Unity built assets like this microphone that you can actually grab and hold, and when you want to talk to someone, you have to push the button. This is deployed on an Oculus Quest or a Meta Quest. It's also available. We're also working at putting onto something like a slightly lower cost device like a Pico. It's portable and we can deploy it fairly quickly, and it doesn't require you to have a whole lot of extra computing power on your site. We've also implemented some biometric feedback. We're in the process of getting that fully integrated. Right now, you're looking at sort of our pilot overview. The heart rate monitor is used to provide insight into stressors that students might experience. And it's been some very, very interesting places where different students have different reactions. It allows them to monitor it. We're looking at the potential of having it live, so you can see what's happening while you're doing it, sort of a biofeedback style, or just in the background so that you can actually do it at review time. In order to make the talking to the machine part work, we're using Azure AI services in order to figure out which way we should go with our presentation. The story needs to move along. All right, the early editions, we would take speech to text, and then we would take with one API call out to Azure, and then we would get the text back, and then we would take the text and we'd fire it off to another Azure service to get back an intent. The latest edition of the software actually does this in a single pass using the natural language understanding API that is available for Unity. So our solution really relies on intents. These intents and entities let us discern
what people have said by categorization. It works. If you've ever said, hey, insert name of your voice bot here, Siri or Alexa or whoever you have, turn on the lights. Essentially, that's what we're doing, but we're doing it with specific language that is within the domain of the student. So in the case where we want to get, and this is a small snippet of our intents from a mental health crisis intervention, we need to convince Bill to be searched or to come with us to a particular destination. So we're looking for the student to identify the right thing to say and use the right kind of words, all in the same sentence. And in this particular case, we have the ability to also say, you must say it at least 3 times, because sometimes you need to just be very consistent and maintain the contact, maintain the information, or maintain communication with the person in crisis. The system comes with some great tools for analysis. This is the analysis of that same Bill scenario. There are we have a testing training split. We have an F1 score, which basically is the average precision of how things are going, and it's a pretty precision and recall are pretty strong. We would like it to be a little bit better, but it turns out it is more or less sufficient to get through these scenarios, very short scenarios with very tightly focused language. We don't need too much discernment. This, again, for this example, we have a confusion matrix that says, well, this is where, and this is good down this line should be nice and solid, so that when it's something is labeled this and it's predicted as this, that's good. So that's very good. This piece over here is kind of bad. Not super bad, but sometimes build justification and identification look overlapping. And that's one of the things that we need to work on from the point of view of crafting the data that go into the system. It's less about what comes out and more about what's going in. I'm just going to pop back 2 slides here. You can see that some of the things that we have very low numbers of utterances. Now, these utterances are ones that we have selected to go in. And so words of insertion is very small. We don't have very many of them right now, but it's enough that we can identify them. For some of the things like agreeing to have Bill searched or convincing Bill to go, we have many more, and it's good enough. In my heart of hearts as an AI researcher person, I hate the need for lots and lots of data. I would love to be able to get through with less and less data. So the research that we've done with this is sort of been in 3 general categories. We've done some research in the Scholarship of Teaching and Learning. We interjected this in the process of teaching, getting students from this is what to say before they get to the live actor role plays. And it actually showed a marked improvement for those students taking on those role plays. We learned a lot about working with the Azure's conversational language understanding. We are trying to find a minimum, and it seems that 15 to 20 per utterances per intent seems to be enough. And we're continuing to refine the libraries so that we can work across different domains. And ultimately, we also did some research on the immersive experience, and user hand selection actually matters. So we've designed two sizes of hand to represent, roughly speaking, well, male and female hands, but big hands, small hands, but also a slider interactive that lets the student choose a hand tone that matches their own hand tones. It improves their immersion. We also, in the immersive experience, found that the voice interaction really does matter. It really does let the students learn the ways to talk and practice the words that they need to do. I'm going to share here the voices of the students talking about their experience.
It was definitely very real because the whole time you can turn around and see what's going on, and it's pretty instantaneous too when you say your response and then how the other people react to what you're saying.
It gives you a little bit more realism because you feel in the room instead of looking at a screen. You're right there, and just the fact that you have to look towards the person, and like my partner's behind me, you have to look over, check on them, whatnot, and you can hear them behind you having a conversation. You're trying to hear the tone of their voice while listening to the person in front of you.
Knowing that I did a VR, knowing that I had been to a scene before, it kind of helped me feel like this wasn't my first time, this was just a second time. And that whole awkwardness of telling someone what to do, that using authority, which is something, I don't know, it's not usually something I would do. It helped me prepare just to talk to someone.
Being able to understand that like what I said was going to have an impact in the VR, like obviously whatever I said was going to continue to move forward or like change the course of things. It's really no different than in real life. Like you have to watch what you say because like it's going to change the outcome of your actions.
So the students actually really did appreciate what's going on there and observed all the things that we were hoping they would observe about what's going on. So for future work, we're looking at using GPT for building our phrase vocabulary. So when we're sitting building our script, we say, well, they need to say something like this. We're looking at using some GPT to generate alternative versions of that, because 3 of us sitting in a room or 10 of us sitting in a room can't think of hundreds of ways to say the same thing. We're also looking at finding out ways to learn and identify tone, pitch, and volume. That's for a future project. And we're also looking at building a bit of a learning management system kind of interface. We'd like to have it maybe adapt perhaps to successive training and randomize the path through. Right now we have pretty linear but branching paths. We're looking at adding some other features for randomizing what's going on. We're actually working with the Natural Resources Conservation degree program at the Lethbridge College right now to build some more scenarios to work with in their programs. And we're also investigating use in healthcare and other industries. We think that this system will work very well, provided that we can get the right language from the subject matter experts, so that we can actually build the right kinds of intents. Lethbridge College has a number of people working in related work. So the START area, which is spatial technologies and augmented reality, something else that starts with T. I can never remember what the second T is. At Lethbridge College, they're developing some things like a multi-agent simulation, where in the VR environment, you meet with a number of characters who've been crafted with tuned GPTs to represent different personalities. You talk to them, you wander around an animated environment with an animated character. In the future, we see that these 2 kinds of scenarios will work together. We'll merge it together once the realism of the animated environment is stronger. I think it will ultimately be converging technology for this kind of solution. And that is the 5,000 mile an hour run through our research. I would throw this open for questions.